So, here's our homework for all our orchestra friends that are not here today. We may be doing 2 lessons. We will find out by how quickly we go. So this artist, now if you had seen the little clip that played with this, the rectangle was moving as she was telling it to sit up and sit up straighter and whatever else. So she's trying to draw a painting of the rectangle. Now when you look at paintings, like these famous paintings, like the Mona Lisa and I forget what the one is called with all the people in the park and these different things. When these artists paint based off real life, are they painting things the size they actually occur?
Not necessarily.
Not necessarily, but are they trying to paint it how it actually looks?
Not necessarily.
Well, okay, not necessarily. But if it's a realist artist, then yeah, they're trying to paint it how it looks. So they need to keep things in the same, what word do we use to mean it looks the same but it's a different size? Scale. So we need to keep them in the same scale. So we know that we need to have some kind of scaling factor. So if we have a scaling factor, there's some kind of conversion that we can make between things. So here we could say that one box or one square of the grid lines over here, what would that equal? What would be my scaling factor to convert from the size of my shape in the bin? That's my copy.
Oh.
If you're late to class, gotta figure it out. That's not going to help. I just love when they think closing that 2 more inches is going to help. So if this edge was 12 inches and now it takes up 2 boxes, James, what's my scale conversion?
6 inches.
Yeah, every box has to equal 6 inches. So then we check, is the top what it should be? Well, if it's 24 inches, how many boxes should it end up equaling?
4.
4, because we'll divide by 6. So we check 1, 2, 3, 4. It is correct. Our figure is to scale. So we could say that this is a dilation. Now, if we get told that every box equals 1 inch, we could determine what the dilation factor, or the scale factor is. How many inches, then, is it representing on the painting or on the grid? How many inches by how many inches? Well, if every box is 1 inch and this is 2 boxes, then that'll be, this was 2 inches and that's 4 inches. So what would be the scale factor or the dilation factor there? If it was 12 by 24, now it's 2 by 4. We already have it. 1 box to 6 inches, but we could just say this is a dilation by, now would this be a dilation by 6 or by 1/6? If this is my original and this is my new. Jackson?
1/6.
It'd be 1. Yep. My new figure is smaller than the original figure, so my dilation factor or my scale factor will be less than 1. But you always want to think about this as multiplication. So instead of saying divide by 6, we say it's a dilation of 1/6. We always want to think about this as multiplication to the original figure. Any questions? Didn't figure. See what I did there. Actually, my first class, my first group ever at Phoenix changed how I say the word figure because they made fun of me and told me I said it wrong.
How did you say it?
Figure. I used to Kashaktan.
A dilation is a transformation that moves each point along the ray through the point starting from a fixed center.
Well, now I can pause for them. So, what's nice about a dilation is we normally like to dilate out from the origin. So notice what we've done here. We've taken a dotted line and connected from the origin through, not to, but through every point. Now, it doesn't have to be dotted. You could just draw this lightly on your paper. But what this lets me do is know that my dilation points will all have to be on these lines because it will keep the same angle from the origin. So if we want to talk about, and you'll get further into angles and things like this higher up in math, but each of these has an angle off the origin that it makes, or I could come out to B and say that this angle, has a larger angle. So even when I dilate the shape and make it larger, it's going to keep that same angle relationship to the origin. So I decide my dilation factor, and I might grab one of my points. Where is A right now? What is its point? A is at 1, 2. So I take A, and I decide where is A prime going to be based off where A began. Well, my dilation factor, or my scale factor, is going to tell me that. So I want to use, where do I want to stop it? Yeah, we'll go here. I want to use a scale factor of 2 here. I want to dilate this by 2. So you could somewhere write that our scale factor or our dilation factor is going to be 2. So what I do to my A prime is I say, well, A prime is going to be twice as far away from the origin as A was, and it has to keep the same direction. So I just double everything in the point. A prime now becomes 2, 4. I can do the same with B and the same with C to get B prime and C prime. And notice that the distance from the origin doubles. So if we used our distance formula, which we've not learned yet, you guys will. That's more of a deeper Math 8 standard. We could use the distance formula. Now we know this is slightly over 2, because it would be 2 if it went straight up, but it goes diagonal, so it's slightly over. And this distance is that same distance, so we know it doubles. I can do the same comparison from B to B prime and C to C prime. The distance from C to C prime will be the same as the distance from the origin to C. Same with origin to B and B to B prime. All the slopes stay the same. The points I could go from by just multiplying the x and multiplying the y. Any questions as of right now? If your point starts on the axis, what happens when you multiply 0 by a scale factor? It still gives me 0. So when my C and my A here start on the x and the y axis, even though I multiply those points by a scale factor of 2, they stay on the axis, because when you start with 0, you end with 0. It doesn't matter what you multiply with. The only point that moves here is B, because D was 0, 0. Multiply them both by 2, and I still get 0, 0. Oh, and then here, some people think this is funny.
2.
There's a groovy transformation they call the dilation. To start, you always enter from a fixed center. Then you can move along the ray, any common scale factor all day. Dilation, dilation, gotta do this transformation. Dilation, dilation, the groovy transformation.
Thank you, Bongo Bob. Your daily dose of coffee shop bongo poetry. All right, sorry about that. We'll move on. Making sure these had a back. I got a set of copies today that did not get copied front and back. Made me very upset. So which of these is a dilation? If it's not, is it anything? Is it anything that we know? So check your ABC image on each of them and see from the pre-image to the image, is there a fixed dilation that I can track, that I can follow? Because remember, we could draw that ray from the origin straight through, and it should connect my original point to my prime point. By the way, do not draw on the Chromebooks. Last year when we were doing this, I had a student who had like a ruler on the Chromebook. I was like, are you drawing on that? They're like, no. They were like trying to just see it, but they were like close, and I was like, don't even, don't touch it.
But you can use those pens. Control the screen.
Yeah, but don't. Because if I do it and it ends up goofed up, that's one thing. I'll pay for it. But if you guys goof it up, that's kind of tough. So what do we think? Do I have any volunteers, or do I need to go out cards? Peyton, what do you think?
I think it's the middle.
You think it's the middle one? Well, let's check our arrays. Does my ray go straight through? It does. Does it go straight through? It does. Does it go straight through? It does, or would if I drew it better. Now, what is our scale factor there, our dilation? So, check your length. BC in my pre-image is the length of 3. B prime C prime is the length of. So to find my dilation or my scale factor, we just take the new length over the original length. We get a scale factor of 2. Now, is there any other transformation up there that we can name? That is nameable, that we know what it is, we've done this. James? A, or the first one, is a translation. Translation what? X plus 1, y plus 1. Now this can be deceiving because at first you see, oh, this ray will work here. Not once you check A and C. It only works for B, and there's no change in scale. It's the exact same size. So it is a rigid transformation, but it is just a translation. And then the last one here, it's nothing. It's like a scaling. I don't even know what to call it. They just aren't relatable. Whoever did it doesn't know what they're doing. So, think about this for a second. Make sure that once you know which one is a dilation, you have a scale factor for it. I will tell you, there is a dilation here. Now remember that earlier, and this might be what you're struggling with, earlier I said that most dilations come from the origin. That does not mean that all of them have to come from the origin. So just like we could rotate around any point on the graph, we can dilate from any point on the graph. Then, from that center of dilation, the rays have to connect. Jackson, what do you think here?
I think it's C or 3, whatever.
You think it's the third one? But wait a minute, Jackson. My rays don't work.
I think that's because the point of origin is actually the center of B and B prime, and the dilation factor thing is 3.
So my dilation center is point B. I'm dilating from point B. So if I draw my rays from there, it goes through A and A prime, goes through C and C prime, and B and B prime are the same location. So then, Jackson, to figure out his scale factor, compared, what'd you use?
C and C prime.
The length to get here, or did you use the point?
I used the length for B.
The length. So we can compare length of 2 to a length of 2, well, I didn't even go far enough. 6. 6 over 2 gives me a scale factor now of 3. I can check that by looking at my length here compared to my length there, and a scale factor of 3 would work. Questions? I didn't figure. Moving on. On the back, you want to draw an enlargement with a scale factor of 3 for that rectangle. Dilation center of the origin. So we want to draw the image. Because remember, what we start with is our pre-image. You want to draw an enlargement with a scale factor of 3.
Suppose you have rectangle ABCD. You want to enlarge it using scale factor 3 with center of dilation at the origin. A is 2 units from the center, so A prime is 3 times 2, or 6 units from the center.
You can
C is 3 units from the center, so C prime is 3 times 3, or 9 units from the center.
Use the distance method.
Similarly, B prime is 3 times as far from the origin as B. D is at the center, so D prime is in the same spot. Rectangle A prime, B prime, C prime, D prime is an enlargement of rectangle ABCD.
Something that looks like this. Now this is what we call an enlargement because from our pre-image to our image, we got bigger. That's kind of self-explanatory. All dilations, this comes back to all dilations are multiplying, but all dilations are not getting bigger. So on the flip side, if it's not an enlargement, then it would be a reduction. So for a reduction of size, our pre-image starts.
Suppose you have rectangle ABCD. You want to reduce it using scale factor of 1/3 with center of dilation at the origin. A is 6 units from the center, so A prime is 6 times 1/3, or 2 units from the center. C is 9 units from the center, so C prime is 9 times 1/3, or 3 units from the center. Similarly, B prime is 1/3 as far from the origin as B. D is at the center, so D prime is in the same spot. Rectangle A prime, B prime, C prime, D prime is a reduction of rectangle ABCD.
The next lesson I think is just as quick. And then maybe we could incorporate another work day. So just note that the big issue that people will have is they work too quickly and they mark the wrong enlargement or reduction or put in the wrong scale factor because they forget you're going from pre-image to image. Always go from original to prime. So just, when you're doing your homework, the biggest thing I'll see, because sometimes the colors flip, it's not always black to blue. So just be careful as you're working through that you pay attention. You're going from the original to the prime point. Cool. Do we think we can do 24-2 also? I think we can. I have big confidence.
Anyone want to pass out notes for me?
I'm going to make this 2 separate videos, so I'm going to